So I'm going to leave that one up to you, unless you feel like you need me to go over one of them. I can do one if you would like me to. Would you like me to do one of them? Which one? C or D? Which one? D? All right, let's do D. And then I'll move on to the rest, okay? And I'm going to pause this video here because talk for today, okay? Enough. Now back to math, right? Here we go. So when you have one of these, and this one is a very scary looking one, make it less scary, right? Like, you just use a highlighter perhaps. Okay, right? So you highlight the big polygon. I call that the big polygon, right? Don't worry about any dashed lines. Worry about this one. So do it with me if you have a highlighter. Some of you I've already converted over to highlighting, right? Some of you are still skeptic. I don't need highlights, right? There it is. So focus on that one right now. That's your first, because there are 0 numbers at first, correct? I don't have a single number on there. So you need to make angles appear. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So n is 15. That's the only n that I'm going to mention in my work here. Okay? Because I don't want too many n's floating around, because then you're going to get mixed up. Okay? All right. So now you decide, first and foremost, even if it's not asking you for it, you're going to find the interior angle. The interior angle of a 15-sided polygon is, remember, 50 minus 2 and minus 2 times 180. So write this down, and it is divided by 2. You know what? I saw a lot of those on the quiz, divided by 2, right? So this is divided by n, right? So good thing that it happened on the AC or on the quiz, right? So it's not on the test. So not a big deal. You fix that on your study sheet, off you go, okay? Brush it off, move on. And then so I would strongly encourage you to be very careful here. And this is what I mean. I get everything is just beautiful, right? So, but it's 13 times 180, right? 13 times 180 divided by 15, right? So make sure you type it in the right way. So that's my first step. That's step number 1. Even if it's not, technically if you scan it, not a single interior angle of that big polygon has a letter attributed to it, correct? So you just have to do it. That's step number 1. So now we know that to any corner we go on that pink one, that angle is 156 degrees. Okay? So then you pick what else you want to pick. I choose like the smallest, perhaps. Like you see this triangle here? That's the one I'm going to zoom in on. So I'm just going to like do this. Okay, that triangle right there. I know that this angle there is what? Is 156. In your formulas, that is called A, right? Like I call that A, the interior angle, so to speak, but then you got to be careful because there could be other letters that are A, so you don't mix them up. But what I need to do there is to find angle A is, it's a triangle, correct? And so you need to use a formula where it's 180 minus the 156, right? This one up top, and you're going to divide it in half. Why am I dividing it in half? Because this is an isosceles triangle, right? Like all of the pink sides here, this only works if it's a regular polygon. So this is an isosceles triangle, so it's 180 minus the interior angle. I will put this in brackets like that because it's very important to get that right. So so you get, am I covering it there? 180, right, minus 156, hit equals, right? And then divide it by 2, or use brackets, whatever works best, right? So angle A, I like to just clearly state that that's angle A. Right? So I've got 156. Oh, sorry, 12 degrees. Never mind, 12 degrees. And then, so that's done. What else should we do? You could do this one or this one. And I noticed that there are two C's. You see that? That was not a joke. That was just, you see that? D, let's call this D. Let's make this, I will call that one D, and then, oh, do you D that? No, that doesn't work. E, F, let's call it G, sure. That probably works better. You can call it X, whatever. But that angle right there is that one. Do you notice that that is outside of the polygon? Do you notice that, the dashed lines? So I'm going to leave it for now. I'm going to park that. I'm going to focus on what's inside. So C next, right? Or B, never mind. It doesn't really matter. It doesn't really matter. But angle B, this one right here, what is that? That's a trapezoid, right? You've got your trapezoid on that in that section, right? And we know that it's a four-sided shape. Think of a square, 90, 90, 90, 90, right? So that's 360, right? It turns out that any four-sided shape adds up to 360. So you need to use the formula. Where am I picking these formulas from? Back up a bit. If you were to go to page 17, no, even further back. Page 16, right? Remember these formulas? I only gave you triangle, trapezoid, and pentagon, but this would continue, right? How would we find these numbers? I'm basically using n minus 2 times 180, right? That's how I get these numbers here. So for the first three here, I'm just going to give you that number. But if it had been a hexagon or heptagon, you just keep using that formula n minus 2 times 180 to come up with that initial number that you need to subtract from. Does that make sense? N minus 2 times 180? Okay. All right. Maybe I'm just too excited about inscribed polygons and you're not. That's okay, right? So B is 360 minus, how many 156, how many of these do I have? There's one in this corner and there's one in this corner, right? So how about we just do arrow so you know this is 156 and that's 156, right? That this angle here and here, I have two of them. So I need to subtract two of the interior angle of that bigger polygon, all of which is going to be divided by 2. That's the key. Okay, I'm going to use, right, put some big brackets around whatever's happening at the top because it's kind of busy there, right? And then you get 360 minus 2 times 156, right? And then I divide that in half. So it'll be 48 divided by 2, which is 24, right? 24 degrees. And then I just state that angle B is 24. So there you have it. Next, I will do C here. And this is a 1, 2, 3, 4, 5, right? This dashed line makes us a pentagon, right? An isosceles pentagon. I have 1, 2, 3 of those interior angles at the top. You see that? And we know that a pentagon, how did you get 540, Mr. Dirksen? A pentagon has 5 sides, right? So 5 minus 2 is 3 times 180. It's 540, right? That's how I get my, this is basically the sum of interior angles for the various shapes that you get, okay? How many how many 156s do I need to take off? There's 3, right? So 3 times 156. You split that remainder in half. I'm going to use square brackets. Maybe a little easier to see. So then it's 540 minus 3 times 156. That's 72. And let's show that step so you don't forget. Okay. That's 36 degrees. So angle C is 36 degrees. Okay. So some of you did the homework. You're just like relaxing, sitting back, right? And just saying, yep, I got that. Yep, I did that, right? And so what should we do next? Let's do D here. Let's do that in order. How would you find angle D? This shape, like whatever shape is here, it's too crazy, right? To try to address that, and it's got all different sides on it. But we know that at this corner, the whole thing is 156. We already know this part, so we just have to subtract, right? So we're going to go 156 minus, I will show what I'm doing here, right? 156 minus angle C. So D is 156 minus 36. That's 120, right? So angle D is 120. I'm going to clearly state that. There you go. And angle E, right down here. E is same thing, 156 minus, because at this corner, right, between the polygon sides, it's 156 minus angle B, right? We're going to subtract angle B from it. So it's 156 minus, what's B again? I'm going to go up here, that's 24. And that's 132 degrees. So angle E is 132. And G, let's not forget about G. How would you do G? You're allowed to kind of just go over here, and this here is, I have two exterior angles here. They're exactly the same. So it's 156 inside, right? So to get this, I'm just going to go 156, sorry, 180. Yikes, that's going to be very messy, guys. Sorry about that. 180 minus 156, I get 24 degrees. This I would just box in to make sure you don't mix that up. Right? So this is 24 and that is 24. Both of these exterior angles are 24, right? I need another highlighter. I'm going to go 24. I'm just going to highlight that there and just show that this angle is 24 and this is 24. Okay. So to get G, I know that G is a triangle, right? So it's 180 minus 2 times 24. And that is 132 degrees. Is this very busy? Yes, it's a bit busy. A test question would probably not have that many angles that I'm asking at the same time, but I could ask of any maybe 3 or 4 of these, right? So be prepared. There's going to be an inscribed shape on the test. No doubt about it. You can like put money down, right? There's going to be an inscribed shape, so you got to kind of just have that down. Have those formulas maybe down, right? Triangle, trapezoid, pentagon, and you should be okay. Oh, if you want to try, we're going to do more of this in the lesson that's following. So I'm just going to leave it in the same video, but let's keep going here to page 19. So we're going to apply what we've learned, but now we're going to show if AB is parallel to CD. So if this line is indeed parallel to that one. And I need to review what happens if lines are parallel, right? Or how do you prove that something is parallel? You need to either show that corresponding angles are congruent, or alternate interior as well as alternate exterior. All of these need to be congruent, right? And then there's the CIA, right? That needs to be what? It needs to add up to 180 degrees. If I can show any one of these, that any one of these is true, then you can conclude that lines are parallel. Okay, so that's going to be our journey here to try to show that. Okay, so if you think about it, let's highlight these are the lines that we're trying to see if they are parallel. They look parallel, but you need to mathematically show this. And right now there are two transversals. So pick one that you want to go with, right? In this instance, you can see that there's a polygon, obviously, right? That is in here. So it's almost like an inscribed scenario. So I'm going to find the interior angle of that. Sorry, 1, 2, 3, 4, 5, right? Like I hope you see that, right? It's a 5-sided. So it's 5 minus 2 times 180. That's my first order of business here. Okay. And I get 108 when I do that. 108, right? And this is the interior angle of pentagon. In case you're wondering what just happened there. So I know I can transfer this over, right? Red pen, I'm transferring over that this is 108 and that this is 108. Okay. Can I add more information to it? What do I know about this angle right here? This one here. These are supplementary, right? So this is 72 and this is 72. Okay. You're allowed to do that. Just fill in as much as you want, but you need to now come over to this side and figure out what's on this side. What can I do at the top to start filling in? You cannot just travel and make assumptions. You cannot say, oh, 72, this must be 72 here because they're alternate interior. Yes, they're alternate interior, but you can't make that conclusion because we don't know if lines are parallel. So you need to like focus on the top here. We know that this is what? 108 as well. We just figured that out. So let's call this angle here X. These are the same, we know that. So I'm just going to focus on X there. Angle X is going to be 180 minus 108 divided by 2. So I'm using the inscribed shape formula there. And that is 72 over 2, which is 36 degrees. So now you know that this is 36. Question is, do I have a name for this angle and that angle, or these two? Do we have a name for them? Jalen's saying no. And that's true. There is no name because this one, right, there has this line here. That's not parallel to this one, right? So don't worry about that. So, but we can go over to this side here. I'm now going to focus in on this one. Do we have a name for these two? They are consecutive interior. Do I have a name for these two? Alternate interior. So you see where I'm going? I'm kind of starting from the bottom and then I go to the top and then I will make those connections. So let's figure out what this blue one is here. What should we call that? Y, you know, that's just how I roll. X, Y. So that's, how would I find that? Well, I know the whole thing is 108. I'm going to subtract the 36 from it. So you're basically, why don't you just start filling this in with what you know how to solve for, right? And then you make the conclusions later on. So this is 72 degrees. So now we go over here and say, hey, this is 72. I just figured it out. Right? There's that 72. And now I can make a conclusion. Yeah. So 72 plus 108, right, is 180. Consecutive interior angles are equal to 180. Therefore, AB is parallel to CD. Or, right, you saw the alternate interior there, right? or alternate interior angles are congruent, therefore AB is parallel to CD. So you really have a choice how to make that conclusion. Both would have been acceptable, okay, but there had to be some work done. Here's what I want to say. I marked the quiz, and some of you actually wrote out, like you gave me like a little paragraph, like I see that this angle and that angle are alternate here and they're congruent. Beautiful. You don't have to use these exact same signs that I'm using. If you just want to write it out, that's fine. Okay, you're doing the exact same thing. Okay. How about I pause here for a bit and I let you do this exact same thing with this one. Try to give this a try. How could you show that lines are AB is parallel to CD? How would you do that? So I'm going to give you about 5 minutes. Just answer it. So first things first, right? And I saw pretty much everybody doing this. You focus on the polygon, right, to get a number in there. So we know that it's a heptagon, right? And so the interior angle of a seven-sided is 7 minus 2 times 180. Don't take too many shortcuts because that's when mistakes are usually happen. So this is 128.57. We got that figured out. So that would definitely be part of the work that I would be looking for. Let's figure out angle A. So I'm kind of guiding you through this one, right? This top one was not guided at all. You had to do everything yourself. So introduce variables yourselves, okay? A is 180 minus 128.57 divided by 2, right? And that is 25.72. Okay, so you would be getting partial marks as you do this. And then I'm going to focus on B. Don't always think it's going to be A, B, C. Do it in that order. It doesn't have to, but I choose to do it that way. So this one is a trapezoid, right? So you got 360 minus 2 times 128.57, and we divide that in half. Square brackets around the whole thing. This one is 102.86 divided by 2. So angle B is 51.43. How's that? Right, so this is important. This is important. All of those are important to me. So I'm building my case. I'm going to start filling this in. 51.43 goes there. This was 25.72. Okay. And how would I find C here? The $1 million question. Not really. But so you're like, oh, what kind of shape is this? If you don't recognize it, don't do it. Okay. Because this is definitely not an isosceles, right? Whatever that is. So focus on what you know. If this is 51.43, right, you're actually finding, when you're finding this angle, you're actually finding this one as well. Okay, so along this corner here, which we know is 128.57, you know two angles already. So angle C is 128.57 minus angle A minus 51.43, which is essentially angle B, right? So angle C here is 51.42. So this is a bit of a rounding. There's a rounding issue here. Okay. But I would never do this to you. Okay, if you're off by 0.01, we will, for all intents and purposes, we'll say they're the same. All right. So we see that. Let's highlight those parallel lines that we're interested in, right? So now you're going to be like, okay, this is a parallel line. This is a parallel line. And it's connected by this transversal here. Okay, so this angle right here, I need more highlighters, but this angle right here and this angle right here would be alternate interior, and they're the same. Okay, so I will say that angle B and angle C are alternate interior angles. So you name them. Right? So these two are alternate interiors. In this case, we can name them. If you don't have letters there, you just say, hey, alternate interior angles. I'm seeing them. Alternate interior angles and are congruent. You should put down close enough right next to it. Therefore, AB is parallel to CD. So that's when you make your conclusion there. Yeah, go ahead. Okay, you want another one? Try page 21. Okay, try page 21 if you want more practice on this type. Page 21 in this booklet. Okay, just it's gonna be right there. Let me see if I have the key to this. I will post it. If not, I will have to make it. I don't have the key yet, so I'll have to make it, but I promise I will post it. Okay. Right, so this is what I want you to do when you see a question like this. Don't freeze and leave it blank, move on, right? What can I do? What do I know, right? I know how to figure out certain angles in here for sure, right? Bring 4 highlighters and then just tell yourself, right, like this is what's happening here. And you'll be amazed how many marks you still score on a question like this. All right, so this is proving lines are parallel. We did that before, but before you just had those apparently parallel lines connected by a transversal. Now we're adding this polygon in the mix. And remember, everything is connected. Everything we've done so far is connected, okay? Oh, okay. I'm gonna stop this video here because it's kind